Welcome back. So let's go ahead and get started on chapter two. In chapter two, you'll find, again, depending on which semester you're taking this class, it might be module two or module three. And chapter two, PowerPoint presentation and demo files are available to you. And the recorded video lecture will be available to you at the end as well. And there'll be one project associated with project two. And again, depends when you take this class, so your due date will be different. And so in some semesters, we do have discussion questions, DQs. In some semesters, we do not. So if you do not see a DQ under your particular module, do not worry about it. But if there's a DQ, discussion question, then you have to complete the discussion question and two feedbacks to your peers as well. All right, so I'm gonna go and get started. So what I'll do today, I'll go over the presentation, the entire presentation, and at the end, I will do the demonstration. I'll talk about the project as well. So just want to make sure that you have access to my PowerPoint, and let's go ahead and get started on PowerPoint. So this particular chapter is called Basic Elements of C++. These are the building blocks of C++. Although in the first project, which we completed last week, we did use some variables like integers and doubles. This chapter actually goes into detail what integers are, what doubles are, and so on and so forth. So we'll learn about this in this chapter, the basic components, what are some of the basic functions, some symbols or operators, what are the identifiers or variables, how to use these operators for simple calculations such as addition, subtraction, multiplication, and division. And then we will learn how to do arithmetic expressions. In the first project, we did something similar. We did gross equals to rate multiplied by hours. That was your arithmetic equation. One side is called the expression. The other side is called, if we have two sides of two expressions with the equal sign, then it becomes an equation. Also in this chapter, we'll briefly discuss string data type as well. And I'll show you how to use the string data type. Furthermore, how to declare a variable, how to manipulate the memory, and how to increment, decrement. In fact, there are special operators, plus, plus, and minus, minus. They are called pre-increment or post-increment or pre-decrement and post-decrement. We'll discuss those as well in this chapter. What else? Some of the syntax errors. Syntax errors are the grammar error of that particular language. We'll have pretty good understanding. Remember, the program is supposed to be cyclical in nature, iteration, which means when you run the program, it might not work the first time. And then you have to go and fix the problems and rerun the code. So rerunning the code and removing those syntax errors is part of the process of learning programming. And then we'll learn about compound statements, which is basically collection of multiple statements within a function. All right, so in the previous chapter, we learned what the program is. We learned that program is basically sequence of instructions or sequence of statements. And to do what? To accomplish a specific task. And specifically, we are talking about application program or as application software. And we identified two types of software in the first chapter. Uh, one was which the operating systems and utility programs, device drivers, and we call them system software. And I had identified that we will not be developing a system software in this class. What we'll be developing is application software. So software is basically sequence of instructions or statements. And the programming itself is a process of planning and creating a program. Now, for example, a recipe should have certain ingredients and the recipe should have certain steps in a specific order. If you mess up the order, you might not be able to get the desired results. And we saw a program, something similar. We created a program, something of similar nature. You can see there are four variables declared here in the main function. In this chapter, we'll dig deeper into what is a main function in a little bit more detail. And here's a simple message. And then notice that these are the values assigned to length and width. And here's the processing. There are two lines of code, which is parameter and area. They are calculating something that is called processing. So two lines of code are basically doing the processing. Two lines basically get the input or some kind of values for those length and width piece of data. And then declaration is happening right there on the top. And then we have some kind of output. So notice that the sequence over here, so declaration happens, the input happens, the processing happens, then output happens. You cannot mess up the sequence of these instructions, otherwise you will not get the desired results. And then it explains the same steps I just identified here, and it's going in more detail. Double data type in this chapter, we'll learn how much data we can store in double data type. And it's just further explaining in this chapter. So when you read that chapter, it will make more sense. Also on the top, I just want to highlight something here. And we'll learn in this chapter, you must have some comments in the code. The comments could be single line comments or multiple line comments. When you have slash asterisk and asterisk slash, that's basically multiple line of comments. But if you have slash slash like this one, so you can have a single line commenting. Commenting is very important because when you work in a large system, you are working with multiple people and you're exchanging your program and sharing your program. And also when you come back to your code after some time, you might not remember the the purpose of the code. It will remind you about those comments as well. This internal commenting inside the code is not compiled. It is not executed. It is just only for reading purposes. So compiler basically ignores these lines of commenting. And today I'll actually show you in the demonstration how do you put the single line comment versus multiple line comments. And it's further discuss the processing part, which I already have explained it to you. Now, in the first project, in the chapter number 1, we talked about a variable. Variable is a placeholder, something, a memory location where you can put some data in there. So when you declare a variable, such as a length or width or area or any one of those variables, like in the first project, we did rate and hours and gross, those variables hold space in the RAM, random access memory. So you can actually read the data from a user, from a file, from a database, from various sources, and you can place the data there. Remember, data is a separate entity and program is a separate entity. Program is supposed to process the data. So the data holder is called a variable. And variable is called variable because it can vary in its value. Let's say the length is 5, it can change it to 6 or 6.5. That's why it's called a variable. So, and there are different ways and different types of variables we will declare, and we'll be learning all of them in this particular chapter. Another important thing is called a function. So notice that the main function, which we used in the first project and we'll be using in the rest of the class as well, the function is basically a program or subprogram which has collection of statements. So, and again, the program allows you to have specific kind of code. You can perform specific kind of tasks. For example, one function can only display the header. Another function can take all the inputs. Another function is responsible for processing. And larger systems, they're a collection of thousands, if not millions of different functions. And the functions interact with each other. In C++ language and Java, C Sharp, and C, these 4 languages, and many other languages, their starting place for a compiler to start the system, start the program is it looks for the main function. So when it finds the main function, that's where it runs the code. So inside the main function, you can place your instructions or code, and those instructions are executed in a sequential order. So just remember that. And of course, we have a separate chapter to discuss how to create our own functions. Right now, what we'll be using either predefined functions, the functions which were created and given to us, and then gradually we'll be adding more and more functions, especially in chapter 3. We'll be adding a bunch of functions, and those are the functions which are given to us from different libraries. The syntax is basically the grammar rules. They specify what is legal and what is illegal. So we have to follow the rules of that language, and rules of the language exist in every language, in human languages such as English and Spanish. Similarly, all the languages in programming, they have the certain rules. You learn those rules. And now we don't have too many rules, but at least once you get used to it, then you know that something is, for example, just to give you a quick idea, which I mentioned in the previous chapter as well, semicolon is required in these four languages, Java, C++, C Sharp, and C. Semicolon indicates that's the end of the statement, end of the sentence. Just like in English language, period is the end of the sentence. And the semantic rules are determine the meaning of that instruction, what exactly that instruction or that line of code will basically provide to you. And so programming language itself is a set of rules, symbols, and some keywords, special words. These keywords, they have special meaning. Those words cannot be used for any other purpose. And gradually we'll learn about the vocabulary of C++ as well. And this is the single line commenting / without any space in between. This allows you to add one line by itself, and that line will not be executed. So this is a single line commenting. So here, this single line commenting will be ignored by the compiler. This is only for internal documentation in the code. You can see there are two lines of commenting there. What if you have multiple lines of commenting? Then instead of putting / every single time, you can use / asterisk and end with asterisk / and then you can have 2, 3, 4, 10, 100 lines of commenting if it's needed. So starting Project-2, you should have, and in fact, some of you probably did in Project-1 as well, you should have commenting built into your code. Some of the tokens, the smallest individual unit of program written in any language. C++ tokens include special symbols, word symbols, and identifiers. In all of these symbols, they have special meaning in that particular language, and we'll start using them pretty soon. And in fact, we did use them in the first project as well. So we talked about the keywords or special words. These are called reserved words. They have special meaning in each and every language because these languages are case sensitive. C++, Java, C Sharp, and C. These are very highly case sensitive, and many of the modern languages are also case sensitive. That int, which we use in the first project, has a special meaning in that language. It basically means integer. And in this chapter, it's going to go into more detail. Integers are basically whole numbers without any decimal places. Then we also use double data type in the first project in chapter 1. Double is basically real values. Real values are either whole numbers or values with decimal places. In this chapter, we'll learn about single characters, and we'll also learn about something called Boolean. It's not shown in this image here, but all these are special keywords. These words have a special meaning in C++ language. Return is a keyword, void is a keyword, constant is a keyword. All these are special keywords. On the other hand, the identifier is the name of something that appears in a program. And identifier, another name for the identifier is a variable. Notice that number could be an identifier. It could be a variable for storing some kind of data, maybe ID number, maybe some kind of other number of rooms in a hotel. The uppercase number is different from lowercase number. These are two separate variables because these languages are case sensitive. So the identifiers or variables, they have certain rules. They must begin with a letter or underscore. I prefer in our class, you always start with the letter. Although it is allowed to start with underscore, but and you'll find some code in online classes, online code as well that some developers, they start their variable names with underscore, but we prefer that all the variables you use in my class, you start with the letter. You can use the digits or numbers, but they must be either in the middle or at the end of the variable name. They should not be, you should not start the variable name with the number. There are other things we used in the first project, cout and cin. Cout means display or console out, and cin is to take the input from the user, console in, and we will be using the cout and cin in this particular project as well. So these predefined identifiers may be redefined, but it's not a good idea. Don't touch them. Don't use them as variable names. Don't do anything. It's going to give you a lot of problem with the compiler. All right, so this is a good variable name. First is a good variable name. It's a legal, although it doesn't tell me what first means. Conversion is a legal variable name. Pay rate is a good variable name. It's very specific. Notice that this variable name here, that is illegal because there's a space in the middle, employee space salary. That is an illegal variable name. Hello and this exclamation mark is an illegal variable name because the only special character we can use with the variable name is the underscore. The plus has a special meaning in a C++ language, so it cannot be used for a variable name. And the last one is illegal because the variable begins with letter number 2. And as we stated in the previous slide, the variable name should begin with the letter. So white spaces are encouraged. You should white spaces after certain kind of grouping of code. And in fact, it makes your program more readable. Do not just have all the code, everything just one after another one. So be generous with white spaces. Now the data types will be working in our class. Mostly it will be simple data type for the first 6, 7 chapters. Then gradually when we get to chapter number 8, 9, and 10, we'll get to structured data type, which will come back to that one a few weeks from now. And then we have something called pointers data type, which we'll be discussing not in this class, but in advanced class in chapter 12, if you join chapter 12 later on. So these are called data types. So three categories of simple data types. We use the integer, and we are going to continue to use the integer for whole numbers. And there are so many different types of integers. There are short integers, there are long integers, unsigned short, signed short, unsigned integer, signed integer, unsigned long, signed long. So many different types. Just to keep everything simple and without going crazy, losing your mind, we'll just stick to integers whenever there is a need to use whole numbers. We are not going to worry about other types of signed and unsigned integers and all these other things. We'll just stick to integers whenever there are whole numbers. And today we'll be learning about characters is for single character. And then also we'll talk about Boolean. Boolean is basically your true or false. Booleans exist in all the languages. Very important data type as well. And then floating data types are called decimal numbers or real values. And we use them in the first project like rate and hours. And we'll learn about there's another one called list for listing purposes, enumeration data type where you can use listing. All right, so let's come to the integer first. Integer actually take 4 bytes of storage in the RAM. So whenever you use an integer, like integer employee ID, it takes 4 bytes. Integer is a pretty large number. It is about plus minus 2 billion or so. So if you have a value which is within the range of 2 billion or so, and it's a whole number, you can use a single integer. But if you feel that your value will be very, very large, then I recommend we can use double. And I'll talk about that one in the next screen. Although it shows over here long, we cannot, our PCs cannot handle such a long integer, such a long, because it takes 64 bytes of storage, but the processing is very complex. So we're going to stick to only integer for our project purposes. And Boolean will be true and false. Character is single character. And I'll be demonstrating all of these in next 30, 40 minutes or so once we are done with the chapter. And this is a good integer, minus, it could be minus or plus. This is a good integer. This is 78 is a good integer. Plus 763 is a good integer. If you have multiple pieces of data, or even if I think it's highlighting here, if you have long values, do not use comma because comma has a special meaning in C++. So do not use comma if you have values in thousands or tens of thousands or millions. There's no need to do that. In Boolean time, we stated it true. True means one and false means zero. And they are very critical in programming, and they allow us to run certain control structures such as condition checking and even looping mechanism. So we'll come back to the Boolean data type a little bit later. And bool, true and false, they are keywords or reserved words. They have special meaning. You cannot use them as variable names or for any other purposes. The smallest integral data type is called char, character, and characters use single quote. Notice the single quote around it. And for example, if somebody has a middle initial A, then you can use a char. Char takes only 1 byte of storage. And notice that, I think the previous one right here, char uses only 1 byte of storage. Similarly, Boolean only uses 1 byte of storage. So here, let's go back one screen here. Yeah, so you can see single quote, lowercase a, or in this case zero. These are all single characters. And in the traditional languages, older languages, they did not have a collection of strings or textual data. So they use single characters and a collection of single characters. That's how we came up with the strings or textual data. And I'll explain that one once I do the demonstration for you. Different character data set exists. ASCII, I showed you the ASCII chart last time. They have different kind of characters in there, and they represent a specific value. I showed you last time the ASCII in the ASCII chart, uppercase A is 65, lowercase a is 97. So they correspond to, behind the scene, it corresponds to the value of those characters in order to manipulate those values. When it comes to the floating data type, again, there are different types of floating data type. For our purposes, I'm going to go to the next screen. We are going to stick to double data type. But there's a float one, there's a long double, there are many other types as well. We are going to just stick for our class double data type. Now, double data type is a very large value. Notice that it's plus minus 1.7 10 to the power 308. It's a very, 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 very large value. You will never be writing a code in my class or probably in your lifetime, which is handling this large amount of data. But if you have to write a program where you're handling very larger than this value, then you can use long double. Our personal computers cannot handle long doubles, but larger machines, they can handle long doubles. Long doubles, they can handle 10 to the power 3000. So 3000 zeros, which you cannot even comprehend how large that value is. So there's a floating data type, which is much smaller in size, 10 to the power 38, and it takes 4 bytes of storage. But for our purposes, we are going to stick to 8 bytes, which is double data type. And we did use that one in the first project as well. So I think that's what it's highlighting here. These are values with decimal points, and they actually can be represented in double data type. You can also show them in scientific notation. I think in project number 4, we will demonstrate in scientific notation. They could be shown like this. And we'll do one project showing in a scientific notation. Also, another advantage of double data type, it has a very high level of precision. Precision here basically means that up to 15 decimal places. You know, when you have a decimal point, 1, 2, 3, 4, all the way 15 decimal places. And I don't think so you will ever write a program where you need that kind of high level of precision unless you work in a scientific or astronomy or some other kind of systems. So although the floating data type float has 6 to 7 level of precision, but double has 15 level of precision. That's what's called double precision. So we'll stick to double data type for the entire semester for our class. All right, so to declare a variable, you simply say, I need a counter. Counter is something you created, should be meaningful. It is designed to hold only whole numbers. Or you have something called interest rate created by you. This is the developer comes up with these names. The names should be meaningful. Names should not be something which doesn't make any sense. Let's say variable C. Variable C might not give me any meaning. Even you'll forget it, or your team members will not be able to recognize the purpose of that variable. But if you have something called interest rate, it is more meaningful. And this tells me it has the ability to store decimal places or even whole numbers as well. The grade is a character. It can store only single character, A, B, C, D, and F, for example. And then you can store the value. You can read the value from the user, or you can, in this case, the value is being assigned to that variable within the program. Then these are some of the arithmetic operators. So you are familiar with some of them, and some of the new ones you will learn gradually. Here we have plus, minus, addition, subtraction, multiplication, division, and modulus is basically gives you the remainder. We'll learn about module. This is a modulus operator, which we'll be using. And when you use these slash with integral data types, the integral result is truncated, no rounding. So you have to be careful if you're using division with integers. So it's going to ignore the remainder because it doesn't handle the decimal places. So you have to be careful when you use these divisions because you might not have the high level of precision. So, but if you use a double data type, then you will get the more high level of precision. So arithmetic expressions basically contain values and arithmetic operators. Some operators are binary, which means they need two sides. Some operators are unary. They just need one side. And parentheses are our friends. We use parentheses generously. Like this particular expression is very confusing. So if you meant 3 times 7 first, or if you meant 7 minus 6 first, you have to put them in appropriate parentheses, just like the same rules apply what you learned uh, in in previous cases also. Let me pause this video for a second. And all right, let's come back to the expressions. Sorry about the pause. All right, so we were talking about using of these operators. So you can see this particular expression is again very confusing because we don't know we have to add first or multiply first. So when you have a specific algorithm or logic, make sure you use parentheses for that purpose. All right, let's move on. And again, the division is being shown here, and we'll be learning all of these techniques in our different projects. Our second project will be learning how to calculate the grades, calculate the averages and totals, and then we'll have a chance to apply those rules. If operator has same types of operands evaluated according to the type of operands, again, don't worry too much about the language here. It's basically saying the same math rules are applicable. Which operator is applied first? The multiplication and division, they are applied before addition and subtraction. So same rules apply here as well. Unless you have two different data types. For example, you have a number which is integer and number which is double. Then how do you apply put them in an equation or an expression? But most of the time, the compiler does implicit conversion. So let's say you are trying to multiply double data type with integer. So compiler might upgrade the integer to double data type in order to have that commonality between those two. But again, it's a poor practice. If you leave it to the compiler, you can do explicit conversion. And again, explicit conversion basically means that I want to convert this number here into a specific type. This is where you provide the type of the data. And I'll be demonstrating this one once I go to the compiler. And it shows you an example here. 7.9 is a double data type, and we are doing static cast. This is a keyword into integer, and it becomes 7. 0.9 is truncated. Here in this case, 3.3, we are converting into integer, it becomes 3. In case of 25, we are converting into double explicit conversion, and it becomes 25.0. So now if you have other data type, which is also double in data type, then you can have similar calculations. Now, something else is introduced in this chapter, which is called the string data type. String data type is a collection of characters. We learned about char earlier in the chapter. Char is basically a single character. What if somebody's name is William Jacob, or which has multiple characters? So in that case, we have to include a special library called string library. Then we can deal directly with multiple characters, textual data. And we will be including that library in our demonstration as well. Data must be loaded into the memory. We saw that. We studied that one in chapter number 1. And in fact, there's something called loader. Loader loads the data. And in fact, you don't even have to do anything on your own. This actually happens behind the scene for us. There's another type is called a constant. Constant is something which is not a variable. Sometimes you want to have something which is fixed, should not be modified. So we use a keyword const, C-O-N-S-T, const. Now this conversion is constant, which means 2.54 cannot be modified. So you can have constant of any kind, character constant, string constant, any kind of constant. The constants are typically, this is not required, but it's a kind of tradition that you make them uppercase to stand out, to make them look different. Even if you use the lowercase, that is still fine. All right, so we have covered what the variables are. Variables are memory location whose constant may change during execution. And here is a variable, double amount due, integer counter, character ch, integer x and y. Notice that x and y both are integers. They can be separated by comma and both are declared here. And string name. So this is how you can declare different types of variables. And we'll be declaring all of these in our demonstration today. Ways to place data into memory. You can actually read the data from a user. We'll be doing that. And we did that in the first project as well. Or you can have the data from sitting in a database and you can pick up the database data as well. So assignment is basically assigning the data to variable. And typically you can use an equal sign, or there are other special functions to assign the data. Here, number 1 is declared here, integer number 1, and 4 is being assigned to number 1. And here on the right-hand side, 4 times 5 minus 11 is being assigned to number 2, and so on and so forth. To save the value in expression, declare a variable of an appropriate type. That is very important. If you know that you might have a data of fraction data type or decimal data type or real type, then you should declare it as a double data type. But if you are expecting only whole numbers, such as room number, then you can declare it as integers. If you anticipate that the variables data can have characters, then you should not declare it as integers or doubles. You should declare it as string or characters. Here's an example, character, and this one, in this case, is empty space. Although here, notice that the variable first equals to 13 and second equals to 10, I prefer when you're learning the coding, you don't declare them in one line, you declare them in separate line. I prefer that you declare each one of these variables in separate lines like this one here. All right, all must be initialized, but not necessarily during declaration, but they must have some value. And we learned in the first project how to read the data. And again, this is what we did. We did cin and these two operators, and we did rate and hours in the first project. Although you can read two pieces of data at the same time, I do not recommend it. While you're learning, I recommend you do them separately. If you have to read two pieces of data, you can read them like this, separately like that. So this is recommended while we are learning. And also we should be prompting the prompt is the message for the user, so user knows exactly what is being asked. All right, and this I'll be demonstrating something similar. The next concept is called incrementing or decrementing. Now this plus plus symbol means the variable is being one is being added to the variable, or the one is being added to the value of that variable. Now this is called pre-increment. This is called post-increment. So for example, if you have 5 assigned to x, then y plus x means x becomes 6 and 6 is being assigned to y. So both of them become 6 in this case. X becomes 6 and y becomes 6. And because this is a pre-increment, so x is incremented to 6 first. Then it is being assigned on the left-hand side to y. So both become 6 in this case. On the other hand, when x equals to 5, and x is still 5 here, so 5 is being assigned to y, but then x increments to 6 because it's post increment. So x becomes 6 after this line and y becomes 5. So there's a slight variation, not to worry too much about it at this stage. And similar thing can happen to decrement, minus minus variable, or before or after. And we talked about giving a prompt to the user, and we use these less and less operator, which we did that in the first project as well, and we'll be doing extensively in the second and the other projects as well. We did something similar in the first project. We said hello world, and we said California, and we also posted some other messages as well. There are special operators. These are called escape sequences. Backslash n means new line, backslash t means tab key, backslash v is backspace. Gradually, you will learn some of these special escape sequences in your code. So some operations, many function symbols needed to run a C++ program. Many of these special operators or objects exist in the previous libraries, which I alluded to that one in the first chapter as well. We use these libraries with the number sign. And if you remember, we did number sign include IOStream. Today we'll be including another library called string library as well. And this is what we did in the first project. We'll be doing this in the second and all the rest of the projects in this class as well. And here it is using namespace std. I had indicated that if you don't use the namespace std above the main function, then you have to use std with all the operators in there. And also in this chapter, we'll be using string library because we want to deal with string data, which is textual data. If we don't have a string library, then we cannot handle long textual data. And our starting point is always the main function. By the way, how do I know it's a function? By looking at the parentheses. Parentheses indicate it's a function. This function is the starting point for our code. So when you run the code, the compiler goes and looks for the main function. When it finds the main function, it goes inside the body. Where is the body? Body where the curly braces begin. That's where the body of the main function is. And once I get into our code, I'll spend more time and explain that to you over there. So do you have declaration statements and executable statements? The declarations are basically you're declaring variables. executable, basically you're doing processing and producing some results. And I mentioned that to you last week as well, that source code is your C++ high-level language code. And that file should be saved as CPP file, .cpp. And once it's compiled, it becomes an object code. Object code is not fully executable until all the libraries are linked, and then it becomes .exe, then it executes successfully. And don't worry about the error message. Once I get the error message, I'll show it to you. The rules of the language indicate what's legal and what is not legal. Here, we're missing a semicolon. It's going to give you an error message. And it might show you not one error, might show you multiple errors. Sometimes the compiler is confused and compiler says, well, you have 5 errors. Basically, it might be just one error. The blank spaces I indicated earlier. You should be generous with blank spaces. And also end with a semicolon. I mentioned that several times. Comma has a special meaning in C++ and most of the languages. And the semantics is rule of the language. What exactly will be what will be the result from that expression or that particular line of code? And naming identifiers use meaningful names. This one is a meaningful name, annual sale. I recommend you use the first word lowercase and the first letter of the second word uppercase. Like annual sale is better. If you prefer underscore, that's fine as well. This particular standard is used by the industry extensively. There are 6 or 7 standards. We are not going to discuss all the standards in this class here, but this one here is called Camelback. Camelback standard is extensively used. There are other snake standards and other standards as well. Here is we are prompting. This is please enter a number of number of values between these this sequence, or then you can grab the value in this variable number. And documentation is your internal documentation with single line or the multiple line commenting. And I prefer you use each one of these in separate lines like this. I prefer that way. I do not prefer that you have 2 variables declared in a single line, although it is legal, but it's a good practice when you're learning, declare them in separate lines. And sometimes you also can combine, this is called compounding. You can combine one complex expression into one. And I'll demonstrate. For example, when you say x times y or x plus y, this particular line of code can be written as this as well. X asterisk equal y. This line of code and this line of code means exactly the same thing. All right, we've finished the chapter, and this is just a summary. So now I'm going to go to the demonstration, and I just want to make sure I share the right screen with you. So I would like to go where my code is. All right, I think you can see my screen, and I just want to make sure I don't want to, because sometimes I pick up the screen and then I go through it. Then in the recording and students, they cannot see anything. So here it is. All right, so first thing I'm going to do is I'm going to include another library. This library is called string library. String library. We included the string library. So now we have 2 libraries. This is the library input output stream for cout and cin purposes. And this library will allow me to deal with the textual data. Then I would like to declare some variables. And before I declare a variable or two, let me just show you that what is the sequence? And I think I briefly mentioned that sequence as well. First, you want to declare and initialize all the variables. So let's say I want to declare a variable called CS11 score, or let's call it score1. I want to declare this variable score1. And I also want to initialize it. Initialize means, because if you simply declare it, it's going to pick up the garbage memory data from the memory. That data might be garbage. So you can initialize that into 0 right there. So it means the data which was sitting in the RAM as a garbage, it is cleared out. So it's a good practice to declare your variable like that. So let me declare another variable of double type. Let's call that variable total. And if you have double data type, it should be initialized to 0.0, not 0, because it deals with decimal places. Let's declare another variable. Let's call it middle initial. And how do I initialize that one? Well, you can have 2 single quotes. These are not double quotes, 2 single quotes. This is how you can initialize. If I want to declare Boolean data type, flag, and a Boolean can only have true or false, and you can just start with true, for example. And then I want to declare finally string first name equals, and I can initialize it to 2 double quotes. So all the data, if it's picking up from garbage from the RAM, it's going to clear all that garbage. So I have declared all 5 types of data types: integers, doubles, characters, booleans, strings. Not only I declared them, I also initialized them appropriately. So initialize to 0, 0.0, 2 single quotes, true or false, and 2 double quotes. Okay, so this is how you want. The first thing you want to do is identify what kind of data you're going to handle and declare variables accordingly. And this will come with some practice and with some experience, but declaration and initialization is the first step. Then think about the project. Let's say you have to read a score, um, And let's say you have multiple scores. So I'm going to just copy this code here 3 times. I'm going to call them score 1, score 2, and score 3. Score 3. And then I'm going to read those scores. So here I'm going to give a message. Please enter score 1. Score 1 for the user to see, semicolon. Then I want to read that score. Score 1. Okay. Score 1. And once that's done, I'm going to copy this line of code, these 2 lines of code. I'm going to paste them a couple of times. Let's change that to score 2 and change this to score 3. And so in that way, there's no confusion. This is score 3. This is score 2. All right, so this is for prompting purposes. So everything looks good. Um, Okay, so we got all 3 scores, we prompted the user, and then the next step I want to do, although I can run the code, and I recommend when you're learning, run the code as soon as possible, run frequently. In that way, you can capture any errors. Let me just show you an error message. I'm going to remove the semicolon at the end. I'm going to run the code, and it's going to give me an error message. It says, you're missing a semicolon right there. All right, let's go and take a look. Here, it's telling me I'm missing a semicolon there. And in fact, it's telling me I'm missing also semicolon here. Let me put the semicolon here after score 3 first and read on the code. And it still doesn't like my single quote here. Let me put a space in the middle and that's run the code and it's happy with that one. It did not like those 2 single quotes next to each other. So when you find an error, don't panic. It's just something you have to tweak in your code. So let's say my score 1 is 44, score 2 is 66, and then 88. So my program ran successfully. Although it did not produce any meaningful results, that's what we are going to do. We are going to calculate the total. And total equals to score 1 plus score 2, score 2 plus score 3. Semicolon. All right. Now, I do see a logical issue here because my total is declared as double, as you can see right there. My score 1, score 2, and score 3 were declared as integers. Now, most probably the compiler is going to do implicit conversion. It's going to convert the score 1, score 2, score 3 automatically to total. Let's actually double check. Sometimes it might give an error, a warning, but not an error message. Let's actually just run and take a look. So I'm not gonna modify anything, simply run it and asking for score 1. Here's my score 1. It's not letting me enter score. I'm gonna stop it and read on the code. If you have a problem like that, don't panic, just exit. Sometimes it freezes. So my second score and my third score is 100. And it gave me the total successfully. So my total was calculated successfully. If you want to be more explicit, you want to have a message with that one, and you can do total like this as well. So I got the total successfully, although these 3 scores were integers. So it behind the scene compiler did the automatic conversion. But if you want to do explicit conversion, we saw in the slideshow, you can do such a thing. You can say static cast, and then you can do integer. Oh, integer, sorry, double. We need to convert into double and something of that sort. And let's read on the code again. So let's read on the code. Here's my score. Oops, score is too large. That's okay. That's okay. If we make a mistake, that's okay. And you can see it did the conversion into double data type. So which means whatever the score to 1255, it was converted into double data type. It was converted into appropriate type. This is better way of writing the code than the previous one. Now you might not see a difference here, But in a real program where you're working with industry, all the data types should match. But if they do not match, then you have to explicitly convert it. Now, how do I deal with the strings? All right, so let's say these scores belong to a specific person. So that person, we are going to ask the name of that person. We are going to say, please enter your first name and semicolon at the end. Then we are going to pick up that first name here, first name. So this name, first name, is a collection of characters and it is declared as a string. We should be able to pick it up. And then I want to display that first name here. And I can say first name. And here I can say space, your total is this. So see how I placed the first name here and a message after that one and the total after that one. So you can actually use the less than symbol, these operators, and should run it. Let's run the code. It's asking for the first name. Let's say the name is Mary. Enter first score, second score, and the third score. And now it tells me, Mary, your total score is, or your total is 191. So it's a little bit more meaningful, as you can see. Now, what if I want to check a condition? Although it is not discussed in this chapter, but for project number 2, we have to learn how to check a condition. What if the score, let's say this total is, uh, let's say it is above a certain number. Let's assume these scores. Oh, by the way, let me also introduce you the single quote versus double quotes. So if I want to do single quote, single commenting, I can simply say author, and I can say your name or my name, whatever name you want to put. And then I have to do another one over here. Date, let's say the date is November something, 2025, for example. Instead of doing all these single line commenting, I can put slash asterisk and I can have many lines of commenting at asterisk slash. So then you can have multiple line of commenting there. So you can actually place it there. This is your program name, whatever the program name is. This is your description. So you can have multiple lines of commenting here, whatever you need to comment. And that's how you can do the multiple line commenting versus single line of commenting. I hope you understand that one. So for project number 2, please make sure you have commenting as shown in the handout, as well as in the instructions as well. If you're missing the commenting, you will not get full credit. You can put the commenting in your code as well, right there, here, asking uh, for the first name from the user. So the user is going to provide that information, as you can see. So this is single line commenting, and that works for us. Now let's assume if the total is, let's say, above 250, I want to display some kind of message. If the total is, let's say, below 100, I want to display some other message. So how do I do that? So in order to check those kind of conditions, which we'll be discussing in chapter 3 in more detail, but I want to throw that one here so you can successfully complete your project number 2. So here, if I want to say if my total is calculated value, if it's less than, this is a less than symbol, if it's less than 100, then I want to say something. I want to say, sorry, you failed in this class. And then I want to put ENDL at the end. What if somebody got not less than 100, between 100 and 200? So in that case, I want to make that person maybe a C grade. Let's assume a D, between C and D grade, or some kind of other message. So I can have another message here. If total is greater than, let's say, greater than 150. 150. Then I want to display a message. You see out, see out. I don't think so. This person is still passing, but I'm just going to display some kind of message. Your total could be better, could have been better, could be better, whatever message you want to display, just so user can see it. What if the person got greater than 250? So if person has, if total is greater than 250, I want to display a congratulation message to this person. So I would say, great job. Now, these all are standalone statements, so they are not connected to each other. So this if is separate from this if, and this if is separate from this if. If this one fails, then it will go to the next line. And if this one fails, then it will go to the next line. For example, if somebody got 250, let's say 260, for example, so this will fail, this condition is false, then this actually will meet the criteria. In fact, let's change that to less than 200. That will be slightly better. So if somebody got 260, so it is not less than 200, it is greater than 200. So then it will go to this line of code. 260 is greater than 250. This will be displayed. Let's actually go and test it. So let's say this person is called Jose and got a very high score, 90 for the second one, 98 for the third one. So now you can see great job is being displayed for Jose. What if somebody got really bad score? Let's say Joe got really poor score and it says, sorry, you failed in this class. But notice that it also says your total could be better. So it's also displaying this message. I did not want that. So in order to control that one, you can add something called else. Else goes with another if. So now this becomes a nested condition. So now this becomes one big condition. So if this one fails, then it will go to this line. And if this one fails, then it will go to this line. So now they're all interconnected. So if this one is less than 100, this will happen. But if it's, let's say, between 101 and less than 200, then it will go over here. So if I read on my code, let's give this person, I'm going to run again, read on my code. And let's say this person is Joe again. You got a really bad score. And there you go. This time, still it's not working. And logic is still not there because what happened, the score is greater than 100, less than 100. In fact, it is exactly 100. Coincidentally, it is exactly 100. So this condition actually um, did not work. And it went to the second condition and it actually worked. And it did not go inside here. It did not say, sorry, you failed. It actually went to this one and it ignored everything else. So actually it kind of worked, as you can see. Now, why I'm showing you this, because something similar will be applying in our project number 2 as well. So I'm going to share my project number 2 with you. All right, so let's go to project number 2. All right, project number 2, share my screen with you. So in project number 2, when you click on project 2, it's going to ask you write a C++ program to get student ID. You know how to do it. You did it in project number 1 when you took employee ID. First name, last name, and 3 scores. I already showed you how to take 3 scores. Instead of score 1, score 2, score 3, you will say CS11, CS12, CS22. I recommend you declare all of them as double. Although you can declare them as integers, but it is logically better to convert them into double data type by casting it. But if you declare all of them as doubles, then it's better. Then calculate the total. I already showed you how to calculate the total. Total equals to CS11 plus CS12 plus CS22. Then calculate the average. Average is basically total divided by 3 because there are 3 scores altogether. So the first part of the code is really simple, really simple. Then you'll be calculating the letter grade. If the average, the total average, not individual score, that average is greater than 90, then you'll display A grade for that person. If the average is between 90 and 80 and 90, then you display B for that person. If the average is between 70 and 80, display C for that person, and so on and so forth. Also, if the person gets an A grade, display congratulations. If the person gets an F grade, display work harder or some kind of message for the user. Now, your program output should look similar to this one. You should have some kind of equal sign displayed on the top just to box out the message. And name of the system is this, name of college is this, your name goes here, the current date goes here, and you take display the ID of the individual student, their first name, their last name, their total is displayed, the average is displayed. And if the average is 90 or higher, you got that student gets an A grade, and also finally they get a congratulation message. All right. So your output should look similar to this one. And you'll be uploading 2 files, one file for the output, which is basically something similar of that kind, which is a black screen. You will take a screenshot of that one. And the second file will be the CPP file of your code. All right. So that's basically what it is for this chapter. And we'll continue with the chapter number 3 later. All right. Thank you very much. Bye-bye.